here are two versions of the equation of an ellipse. We can tell it's the equation of an ellipse because both the x term and the y term are squared. If you remember, in a parabola, only one or the other was squared. Here, both x and y are squared. There is plus in between. My x terms and y terms are added. That's in both versions. And part of standard form is that we have equals 1 on the other side of the equation. The difference is actually pretty subtle. It's just the location of a as opposed to b, whether a is under the x term or a is under the y term. So you may be saying, how the heck am I supposed to know what a is? And there's actually a really short answer to that question. A is the big one. A is more than b. So pretty much a and b are telling us which way is the long way of the ellipse and which way is the short way. If a is with the x term, if the bigger value is underneath the x term, that tells me the major axis, the long way, is parallel to the x-axis, which is to say horizontal. If a is with the y term, that tells us the major axis, the long way, is parallel to the y-axis, also known as vertical. So I have a major axis, the long way, got a minor axis, the short way. The point where they intersect, not surprisingly, is the center. And the center of an ellipse, we can tell from the equation, it's supposed to be an n, has coordinates h, comma, k. H from the x term, k from the y term. So then, what is a? If I go a distance of a along the major axis from the center, so I'm going to go a one direction and a the other direction from the center on the major axis. I'm going to call those points the vertices. Those are the farthest points from the center in that direction. So 2 vertices for an ellipse. If I go a distance of b along the minor axis, I get 2 more points on the ellipse. So this is a distance of b from the center. Some books give these points a name. I've seen co-vertices as a name of these points on the minor axis. I like having a name because they're easier to talk about when they have a name. But in any case, we're going a distance of b. And if we know a and we know b and we can place those points, now we have enough to draw a graph. Draw carefully. Your ellipse should look like a nice rounded ellipse and not so much a football. Ellipses are never pointy, ever. Another feature of the ellipse, it has 2 vertices, so it has 2 foci. Each focus is a distance of c away from the center, so we're going to call that c. There isn't a c in the equation, but we can figure out what it is. So that point is the focus, and there are 2 of them. In an ellipse, the Pythagorean relationship looks like this. A squared equals b squared plus c squared. So if you imagine taking this little segment of length a between the center and the vertex and sliding it up until one end is on the focus, the other end will be on the point on the minor axis, like that. Of A, B, and C, clearly A is the longest side, so we get A squared equals B squared plus C squared.